Greetings. I want to talk now about what is commonly called trigonometry, which is three-sided measurement, translated. And we're going to talk about the background to trigonometry and the meanings of the words sine, cosine, and tangent. The word sine comes from originally, it is the shape, if you like, of a well-hung curtain, or the curve at the bottom of a Roman emperor's toga, or even originally from the Arabic for bosom. So these words have meanings. They're not simply there to confuse you in trigonometry or arithmetic or mathematics. The point is that the sine, cosine, tangent, most of you have been taught, I would imagine, is to do with right-angled triangles. However, the sine, the cosine, and the tangent are actually curves, and it's very difficult, in some ways, to imagine where where curves can evolve in rigid right-angled triangles. Anyway, the word sine, as I said, means this shape here, and it actually comes from a circle. I will go on to describe cosine and tangent later. If I can just draw a circle, let me do a rough circle here. Okay, because the sine, the cosine, and the tangent are all curves, we should be able to get to them by approaching curves. So what we need to do really is to take a radius from this circle. That's not right in the middle, but anyway, imagine that's a circle, imagine this is a radius, and we're going to rotate it anti-clockwise. Now what I'm going to do is maybe I'll take that up to there, and maybe I'll take it up to here, and then straight up. And if we're rotating this, let's call that 30 degrees, which is this angle here. And let's call this 60 degrees, and let's call this 90 degrees. So that's the three angles. Now, so far we've got a circle, we've got a radius, and we've got a rotation, an anti-clockwise rotation, but we haven't got any triangles. But what we could do, I think, is supposing I drop where the radius touches the circumference, and drop a line down there, and call that a right angle, which is what it is, hopefully, if I've drawn it properly. Now we have a situation where the radius is actually the hypotenuse of a right-angled triangle. And yes, it is hypotenuse. Much of what we deal with is Greek and Latin. This is Greek, and hypotenuse means the long side. And the hypotenuse is always the long side, and it's always the side opposite the right angle in a right-angled triangle. By the way, just if I can... if a triangle is not a right-angled triangle, and we need to use trigonometry to prove any parts of this, what we can do is quite simply drop a line down from the apex of the triangle, and we have two right-angled triangles from where we can use now sine, cosine, and tangent to calculate lengths and angles from the information given. At the moment, we've got a situation anyway here where the sine, this is a right-angled triangle. Now I've drawn from dropping that down. I can draw another line down here from 60. And I beg your pardon, what we're seeing here is that this side of the triangle is opposite. This is the hypotenuse as described earlier. This is opposite, and this is adjacent or next to. So opposite, we know what opposite means. Adjacent means next to, juxtaposed. And the situation here is that the opposite side is getting longer as we rotate anti-clockwise with the radius, which is the hypotenuse, anti-clockwise round this circle. Oddly, we're going to come to a situation whereby here the hypotenuse and the opposite side are the same length. Now that is going to be a very, very strange triangle. You can't have a triangle with the opposite and the hypotenuse the same length. However, your calculator, and as far as I'm concerned, all trigonometry is perfectly capable of that. Therefore, we're not really necessarily only talking about right-angled triangles. We're talking about what comes from the process of going around a circle. Yes? So if I can describe that now better, maybe, what I'm going to do is to draw a graph against angle or time, because if something's moving, there must be time involved because we have speed, and speed is distance divided by time. And therefore, I can draw a line here, which is the x-axis plus x. And if I take the angles changing, this is angles, the angle being this angle here, this one here, this one here, going all the way back to the original angle. And what we can do is we can plot a graph showing that and we carry on going round, and so on, and we carry on going round until we end up back at 0, and then we come round the bottom, and we change direction here. This is going from right to left. This is now going from left to right. So this is a change in direction. This is actually called negative. But negative is not less than positive, it's the same as. So a negative value has the same magnitude as a positive value. And if I was to plot this graph, I'm going to do it roughly, we would end up with the sine wave I originally talked about. So this trigonometry, which is, as I say, a three-side measurement technique, actually doesn't always involve triangles. It mostly involves circles. However, we have got triangles here, yes. But if the sine of 90 means that the opposite over the hypotenuse is the same length, how can it possibly be a triangle? It can only be a straight line. A little bit of maths here. If we said that, if the hypotenuse is 1 unit, whatever the unit is, and the opposite is also 1, then the answer is 1. And sure enough, if you look on your calculators, the sine of 90 is 1. However, we can't have a triangle where the opposite over the hypotenuse, well, is the same number. You couldn't draw a triangle like that. It is physically impossible to draw that. I don't care what calculator they've got or who your teacher is. So we here have a sine wave. And it is more to do with circles than it has to do with triangles. The relationship, however, the relationship between the opposite and the hypotenuse in this particular case is called the sine, and that produces a curve, which is this shape, and that comes from rotating a hypotenuse, which is actually the radius of a circle. Yes, okay. In these circumstances, at 30, 60, 90, or anywhere in between 45, 22, I don't care, any place in between, from here to here, yes, you can draw a triangle, but you certainly can't draw a triangle at 90 degrees. Equally, you can't draw one at 270 degrees. So far, so good. Now, let's have a look at the cosine. What does this co mean? Why do we have cosine? Well, if you look at the word complement, okay, you've heard of the word complement. Normally, in your way of thinking, maybe the word complement means to say something positive about somebody else, or say something positive about a situation or a circumstance or a building or a car or whatever. But that's a different spelling. This is an E, and it's a complement. And what it means is that whatever value we've got, name a number between 0 and 90, I don't know, 32. 90, the sine of 90 is 1, which we've agreed here. Now, if I want to find out the sine of 32, use your calculator and find out what it is. Now, what number do I need to bring 32 up to 90? Well, 30 from 90 is 60, minus 2 is, say, 58. Okay. So we've got 58. Now, the cosine, this is degrees, The sine of 32 is a number, and the cosine of its complement, to bring it up to 90, is 58. Therefore, it is the complement of the sine. The cosine is the complement of the sine. Cosine. Cosine. There we have it. If you check, you can check your calculator if you want. 32 degrees, the sine of 32 degrees is the same as the sine of 58 degrees. Yes, that's right. Fine. Now, let's have a look at tangent. What does tangent mean? Well, tangent cannot, once again, be directly related to a right-angled triangle, because it is once again a curve and doesn't really relate to a right-angled triangle at all, except in this context. If I draw a line there, I'm just going to draw, that's a sine, that's a line that's opposite 60. Okay, I'm going to put that there. Now the word tangent means touch, to touch. And what I'm going to do is to draw a line, any line, a straight line, that touches the circumference of a circle, must be at right angles to a radius at some point around that circle. So we've got touch, tangent. Now, if we come back to, I'm sure you're all familiar with something called SOHCAHTOA. And with the sine, it's the equals the sine of an angle equals the length of the opposite, that is the side opposite to the hypotenuse, opposite to the angle itself, over the hypotenuse, which is the long side. And as we've discussed previously, if this is 1, and that's 1, then the answer is 1, and the sine of 90 is 1, and that's there, and there's no way you can draw a triangle like that. Please try. The cosine is the adjacent, which is the side that's next to the angle, the one that's touching the angle, that is not the hypotenuse, over the hypotenuse itself. I'm writing this out more clearly than here, but you can see what I'm saying. Now here the situation is that we're talking about the complement of the sine. Therefore, whatever number needs to be added to the sine to make it 90 becomes the cosine. And if you can check it yourself, as I've said earlier. Now the situation here, though, is that 90, what do you add to 90 to make 90? Well, nothing. So therefore, the cosine of 90 is 1. 0. I beg your pardon. The cosine of 90 is 0 because you add nothing to 90 to make it 90. We can then now plot the graph for the cosine. And you'll see that it's the same shape as the sine wave, except it's shifted by 90 degrees, which is the difference between the sine and the cosine is 90 degrees, and it's shifted, I'm sorry, it's not a very good curve, but it's shifted by 90 degrees in a direction. It's exactly the same shape. If I carried on the cosine wave, it would end up being a sine wave. It's exactly the same shape. What we have to also understand is that this part here is not a trough. This part here is not a trough. These are both peaks. What we've done by changing polarity, that is going from positive to negative, is change the direction of the flow as we're going from right to left. Here, when we get down to 180, we're going from left to right, back to 360 or 0. The tangent is a completely different fish. It simply means touch, and the tangent is the length of the opposite over the length of the adjacent. This is all perfectly legitimate trigonometry and is practiced and used in engineering and science universally and perfectly acceptably, but what I wanted to explain was this is not all to do with triangles, it's all to do with circles. I may have confused you, I may have helped you, I don't know, but I hope I've entertained you. Thank you.